question 4 on the quiz. Okay, this was a common one I had a lot of questions on because people aren't wanting to draw it out. I promise you things will make more sense if you have a picture of it. Okay, they gave you the basic outline of the triangle. They gave you triangle UNC, but there's a lot of information that's not marked and labeled in here that it would make it easier on yourself if you would mark it. So I'm going to put it into the smartboard so I can write on it. Okay, and you had scratch paper you could have drawn this onto. You see your coach?
Mm-hmm.
Okay. All right. So now I'm going to mark it up. Okay, so it says B is the midpoint of UN. So I'm going to mark B on here in the middle of UN. Okay, it says G is the midpoint of NC. So I'm going to put G on here between N and C. It says if UC is 16 centimeters and the triangle is dilated, will we close that door for me, please? You finish? If the triangle is dilated by a scale factor of 2.5, what will be the length of BG? Well, here's connecting B to G. That's what we want to know after the dilation. So we have 2 ways we could go about this. We could go ahead and find BG right now and then scale it, or we could scale UC and then find the new B prime G prime. Does that make sense? You could go in either order. Okay, so right now, if I wanted to know the length of BG, what would it be? How do you know it's 8? That's correct, but how do you know that? Why is it half of 16? What is BG? It's a mid-segment. When you connect a midpoint to a midpoint, you have a mid-segment. Okay, they told you that B is the midpoint here and G is the midpoint here. So BG is a mid-segment, which is half the length of the parallel side of the triangle. So your answer is not 8. That's prior to the scaling. So now we have to multiply the 8 by 2.5. Does that make sense? Yes. Your other option is to scale first. You could take 16 and multiply it by 2.5 and then take half. You could do it that way as well. That would work too. Okay. So are we okay with that one? Yes. Okay. Times it, that's it. That's it. That's so yeah, 20 is your answer here. Okay, I get it. Yeah. Yes. Okay, so if I plug that in, I can see, double check that we did it right. Yep, that's it. Okay. The other that I added in, I'm trying to find the teacher created ones because I put these in here specifically because they're similar to test questions. Number 14. So number 14 says triangle ABC is similar to QRS such that A, B, and C correspond to Q, R, and S respectively. The measure of angle B is 62 degrees and 3AB equals QR. What is the measure of angle R? Again, I promise things make more sense when you have a picture. So draw it out. Okay, so let me get my little camera guy here. So if this is the case,
Oh, I'm also a freshman. He's compliant.
All right, so we've got triangle ABC and QRS. So I'm going to draw them out because they tell me that they are similar. And you don't have to draw them to scale. It doesn't matter. You can if you want, you can draw one smaller and one bigger. The main confusion that I got on the quiz as people were asking questions, one is with the wording of this, such that A, B, and C correspond to Q, R, and S respectively. Respectively just means in that order. So the first letter A goes to the first letter Q. And I'm actually gonna make A my bigger on my bigger triangle. Now, if you didn't, that's not a big deal. Okay, B corresponds to R. And C corresponds to S. Now, the other main thing that I got asked about a lot, I need y'all side conversations to stop, please. It is distracting. Was this statement right here. A lot of y'all got that angle B is 62. Okay, so you can come in here and you can label angle B as 62. But the other piece of information was that 3AB equals QR. That literally means, I don't know why the 3 is like slightly down. Maybe that's what part of the confusion was. I don't know why it did that. But that just means 3 times AB equals QR. So AB and QR are corresponding sides. So they're telling you that AB is 3 times as long. So we don't know the numbers. Like if QR was 2, that means that this would be 6. It's just, they're telling you your scale factor is what they're telling you for the side length. Okay. That means the scale factor is 3. Does that make sense, guys?
Yes.
Now, do we need the scale factor to answer for the measure of angle R here? Not at all. Because if they tell me they are similar, I know that corresponding angles are congruent. And what corresponds to B? R. So if B is 62, what is R?
62.
That's it. That was your answer. Okay. This was extraneous information that you didn't need. Sometimes you have to decipher what's given to you and determine what's important and what's extraneous. What do you not need? Okay. So that wasn't like a trick question or anything. It's just you have to be able to do that deciphering. You have to analyze, okay, what's important here? What's not important? What am I using? Yeah.
But I still have a problem with the shine radical form, like the square thing. I gotta fix it. So I'm gonna simplify.
Okay. I think it's number 20 or one of these asks us to do that, so we'll look at one of those. Okay. Another teacher created one that I added was 17. Oh, here. This is it.
Oh, it is?
So number 17. Yep. This is geometric mean. This was 5.5. This was like the last thing that we talked about in our notes. You are not going to be given the formulas for geometric mean. Okay, those are the only formulas that you need for the whole test. So you should be able to, learn those formulas. I'm going to write them out here. Okay, so these are sides of the original big triangle, right? They're the legs of GHK that we're looking for. And remember the leg rule said that the leg, let's start with Y, the leg squared is equal to the portion of that hypotenuse. Here's the whole hypotenuse. Okay, what is that whole length? 40. Okay, now the portion that corresponds to the Y side would be this piece, right? So how long is that? 30. Okay, so Y squared, the leg squared is equal to the portion of the hypotenuse times the entire hypotenuse. So we would do the 30 times 40, which gives us a really big number. And then you have to take the square root. Do y'all know if that's a perfect square or not? And if you don't, you get scientific Desmos. So you get to check it. It's not a perfect square. So that means that I need to do my factor tree. Now these you can pick any factors. So you could pick like 120 and 10, right? Or you could just start with what got you here. 30 times 40 got us to 1200, didn't it?
Yes.
So maybe it's easier just to start with those. Okay, and now you are breaking each of these down. You keep adding branches until you have nothing but prime numbers. Okay, nothing but numbers that only factor is itself in one. Okay, so what could multiply to 30? Taylor?
13 and 2.
What could okay, I heard.
I'm sorry,
15
I was
and
like listening.
That's okay. Okay, so 2 is prime, so I can't take 2 any further, but 15 can keep going. What multiplies to 15?
2, 5.
Good. And those are both prime. Nothing else multiplies to these except 5 times 1, 3 times 1, 2 times 1. That's what a prime number is. Okay, but 40 we can keep going. What would multiply to 40?
10 times 4.
Okay, what would multiply to 4?
3 times 2.
Now 2 is prime. What would multiply to 10?
5 times.
And those are all prime. So now here's all my prime numbers, the end of each branch, right? So what I'm looking for are pairs. Okay, so 2 of a kind. So there's a pair. Look at that. Even though they're not next to each other, they can be a pair. So I've got 2 pairs of 2s and a pair of 5s, right? So 2 2s and a 5 get to come out. Unfortunately, that 3 doesn't have a partner, so he stays inside.
Okay.
Okay, so then whatever got to come out, you multiply. Whatever stayed inside, you multiply. So 2 times 2 times 5 gives us 20 root 3. So that is our y. Now we would do the same process on the other side with z. Z is a leg. The leg squared is equal to the portion of the hypotenuse, the 10, times the whole hypotenuse, which is 40. So this one, we end up with z squared equals 400. Okay, now 400, if you take the square root, is that one a perfect square?
No.
That one is.
Oh.
20 times 20 is 400. So that one, we don't have to do a factor tree. It's just 20.
Okay, I think I get the factor.
Okay. So now that relationship, how we set it up, you are going to have to know that. Now, I think there was another one on there. It was not one of the teacher created ones, but there was another geometric mean where you had to find the altitude, I believe. Yes, so this one is asking for the altitude, BD. So remember the altitude rule. Guys, y'all please stop your side conversations. Okay, the altitude rule is similar to the leg rule, but it's the altitude squared is equal to the piece times piece. Okay, so what is 4 times 4? 16 is the altitude squared. So what's the square root of 16? So this one happens to also be 4. Okay, they don't all come out that way. They're not all like that. Let's get one that's not the same. Okay, so like this one, the altitude's given and you're looking for the other piece. So this one you'd have to work backward. 18 squared would equal x, our missing piece, times 54. So you would end up doing the 18 squared, and then you would have to divide out the 54, and you're left with 6.
I got you back in.
Okay. All right. So that's the geometric mean question. Okay. The last one that I added in was number 20. This has no calculating to do, But I need you to understand the relationship that's happening when you have a mid segment. Because here they tell you KT is parallel to NO. Okay, so these are parallel signs. Okay, not, we learned in, I want to say it was 5.4, maybe it was 5.3, but in the middle of our unit, we talked about how when a parallel line cuts through a triangle, it creates similar triangles. This nested triangle, KET, here, is similar to the outer ENO. Okay, so because those are parallel, I know this nested small triangle is similar to the outer big triangle. Okay, so they want it. Now they also tell us that KT is half of NO. So if it's half, doesn't that mean it's the mid segment? Yeah. So knowing that the mid segment is parallel to one side and half that length, that you have to know that. That was back in unit 4. Okay, so we have to understand, oh, because it's parallel and because it's half the length, that is a mid segment. Okay, because one of the statements down here says that the triangles are similar because KT is a mid segment of triangle ENO. That's true. Okay, because if you draw a mid segment, you are creating similar triangles. Okay, so that one is a true statement. Hang on a second. Let me finish this. I'm in the middle of recording. All right, so the other ones, let's read through the other ones. It says the triangles are similar because their corresponding angle pairs are all congruent. Well, obviously, E89 is going to be congruent to itself in both triangles, right? Angle E is part of the small and the big triangle. They share that vertex. Okay, and then this 38 is congruent to 38. Now, triangle sum theorem tells us we could find this missing third angle because the 3 angles have to add to 180. And we could do the same thing in the big triangle, and K and N will come out the same. Or because these are parallel, you could immediately know they're going to be the same because they're corresponding angles. Okay, so whichever method you think about it, this angle K in the small triangle is congruent to angle N in the large triangle. So yes, all of the angle pairs are congruent. So yes, they are similar. Okay. The second statement says the triangles are similar because they share a common angle at vertex E. Yes, E is part of both triangles. And angles ETK, that's this 38, and O, that's this 38, are congruent. So yes, even with just those two, because angle is one of our similarity theorems. Triangle similarity theorem by angle. That is enough information to prove that. So those first 3 are all true statements. The last one says the triangles are similar because their corresponding side lengths are congruent. You know nothing in this image about side lengths. No side length is labeled in the picture. No side length is given. There are no markings. Nothing. We know nothing about side length. And even if the corresponding side lengths were congruent, that would make the triangles congruent. Okay. For triangles to be similar by side length, we need to know that they are proportional. Okay. So this is the only one that's not true. And I think a lot of people missed this maybe because they didn't read carefully, which statement is not true. Feel okay about that one? Yeah. Okay, so that's all the ones then that were teacher created that I added in because there will be similar ones on the test. Delta Math had some good practice with the other types. I didn't need to create those. Okay, so you've got your correction assignment that you can do to earn back the points for that quiz grade.